Dear students, welcome to our science episodes. Today we are going to discuss distance and displacement. Distance and displacement. According to the previous lesson, we discussed physical quantities, and we said that there are scalar quantities and vector quantities. Scalar quantities are represented by a magnitude, a number, and a measuring unit, while vector quantities are represented by three information: a magnitude or a number, a measuring unit, and a direction. Motion is defined as change in position. If the object is changing its position, it's moving. And motion is described by a distance and a displacement. You may think that they are the same, but they are not. The change in position or the motion depend on the path of the moving object between the starting point and the end point or the end position where the object stops. So for example, this blue car will move from the point A till the point B. The distance covered actually is represented by this dotted line. It's 9 meters, while the displacement is only 4 meters. We can say that the displacement is an imaginary straight line between the start point A and the end point B. It's a straight line. It's not the actual path of the car. It's just a straight line, the shortest distance between the start point and the end point. The distance is scalar quantity because it has a number and a measuring unit. However, the displacement is a vector quantity because it has a number, a measuring unit, and a direction in addition. So here is the question for you. What is meant by the distance covered by a moving object is 20 meters? It means that the actual length, this is the actual length covered by the moving object from the start point till the end point, is 20 meters. This is the actual path or the actual length covered by the moving object. Here we go. Now, as we discussed before, the difference between the scalar and vector quantities, now we will discuss the difference between the speed and the velocity. In this diagram, you can see that the start point is A and the end point is D. This means that the moving object will move 30 meters in this direction from A to B, and then from B to C 60 meters in 20 seconds, of course, and from C to D 30 meters in 10 seconds. And here is the cardinal directions: the north, the south, the east, and the west. So the total distance covered by the moving object is from A to B 30, plus from B to C 60, then from C to D 30. So this means that the total covered distance, the actual total covered distance, is 120 meters. The total time taken to cover such distance is 30 seconds from A to B and 20 seconds from B to C, and then 10 seconds from C to D, which is equal to 60 seconds total. The speed of the moving object is, of course, the distance over time, or the distance divided by time. 120 divided by 60 equal 2 meters per second. This is the speed. But when I want to talk about the displacement of the moving object, it's just a straight line. It's not the actual covered distance. It's a straight line directly from the starting point till the end point, which is 60 meters in the east direction. So this is the displacement represented by the dotted line, 60 meters in the east direction. And now the velocity is 60, which is the 60 meters divided by the time, which is the 60 second to the east. So the velocity is 1 meter per second to the east. Notice that when we measured or when we calculated the velocity, we used the total, the displacement, the distance covered, not the actual distance, the displacement actually, which is 60 meters, and the time, the total time taken for the journey. So 60 meters divided by 60 seconds, it will be equal to 1 meter per second, but we have to include the direction. So velocity is equal to the displacement over the total time. But don't forget to include the direction as well, because it is a vector quantity. It's measured in meter per second or kilometer per hour. It's having a magnitude or a number and a measuring unit in a certain direction. Don't forget the direction. Also notice that when an object moves in a straight line in a constant direction, its speed is equal to its velocity. Yes, if the object will move in a straight line in a constant direction, the speed is equal to the velocity. Let's take a look at this animal. This is a cheetah. It's one of the fastest animals, where its speed reaches 27 meters per second. If you want to determine its velocity, you should define the direction of the movement. So, does the cheetah move to the west, to the north, to the east? You have to define the direction of its movement. And we say, for example, that the cheetah's velocity is equal to 27 meters per second in the east direction. Here is a question for you. A person covered 150 meters to the east in 10 seconds. If he's giving you the direction, then this is the velocity. Then 60 meters to the north in 15 seconds. Then 150 meters to the west in 20 seconds. Calculate the distance covered by the person, the displacement, velocity, and average speed. Let me tell you something. The best way to solve this question is by drawing. So let's draw it together. This is the starting point, and this is the direction of movement. So from A to B, 150 meters in 10 seconds, and the direction is to the east. From B to C, 60 meters to the north in 15 seconds. And then from the C till D, it's 150 meters in 20 seconds to the west. Look how it's easy now. When you draw it, you can get the distance covered by the person. So the distance covered by the person is from A to B, and then from B to C, and from C to D. This is the actual distance. So 150 meters plus 60 meters plus 150, it will give us 360 meters, the actual distance covered. While the total time taken is 10 plus 15 plus 20 equal 45 seconds. What is the displacement? It's the shortest line, the shortest straight line from A, the starting point, till D, the end point, in a certain direction. So it is 60 meters because this distance is equal to this distance. So it's 60 meters in the direction of the north, because this is the start point and this is the end point. 60 meters to the north. Average speed is the total distance covered over the total time taken. So the average speed is 360 divided by 45, which is 8 meters per second. While the velocity is the displacement divided by the time taken. So it's 60 over 45 or divided by 45. It will give us 1.3 meters per second. And don't forget to include the direction to the north. What is the direction of the velocity? It's the direction of the displacement. What if the person returns back to the start point? So he will not stop here. He will continue to the starting point, the A. The displacement now will be 0 and the velocity will be 0 too. Let's watch this video together.
Today, we will learn about what is distance and displacement. Lot of you will say, both are the same thing, just different words. But no, it's not. So let's know first, what do you mean by distance? It is the total length of path covered by object, without specifying its direction. Then, what is displacement? It is the overall change in position of an object in a specific direction with the shortest distance traveled. Or let's say in simple terms, it is the shortest distance traveled in specific direction. Still confused? Let's take one example. Let's say, I have to go to my friend's birthday party, and his house is 10 km to east from my house. But, here I take different and longer route, as I have to buy gift for him, traveling to about 20 kilometers in total. So here, the destination is same, but the path traveled is different. Then, what is the distance, and the displacement, of the car here? Come, let's see. So, if I travel straight 10 kilometers to east, to my destination, it will be the shortest path I can take. Hence, what are we getting here? When I say 10 kilometers to the east, by shortest path. Yes, correct, it's the displacement, but now, as I have to buy gift, I am taking the longest and the indirect route, with no specific direction, but reach the same destination. So, what we get here? When I travel 20 kilometers, with no specific direction, taking the longest and indirect route. Yes, it is the distance. Now let's say, if I travel 20 kilometers, from one start point, and at the end, stop at the same point. Then, what will be my distance, and the displacement? Here, the car starts traveling 20 kilometers from one point, and ends at the same point. The distance traveled here is 20 kilometers. But the displacement is 0, as the starting point and the end point of the car is same, or say, the origin and the destination of the car is the same. Hope you all understood the distance and the displacement.
Dear students, thank you for watching and see you later in other episodes.